Well, it's me again, but yes, Jeremy unfortunately couldn't make it, so I'll be giving his talk on his behalf. And it's about exploring how event-based cameras can be used for meteor science. So, as we all know, classic cameras or frame cameras are widely used in meteor science, and they can do both astrometry and photometry up to 300 hertz. And on the other hand, photometers can do photometry up to 5 kilohertz, but no astrometry, of course. And potentially, event-based cameras can do both at much higher frequency, so up to 100 kilohertz, and much higher dynamics as well. Um, so how does an event-based camera work? At the pixel level, the tension created by the absorption of a pixel is canceled out by an opposite tension, the V-bias difference that you see here, and therefore the range of the dynamics is large, and the time response is at the order of nanoseconds, and the quantum efficiency of event-based cameras is also quite high, around 90%, and we'll also see how it works visually later on. And sort of to evaluate the capabilities of the event-based camera for meteor science, an observation campaign was organized during the 2024 Geminids. And as you can see on this picture, the event-based camera was mounted in parallel to the moment instrument, which is a suitcase that is comprised of 5 classic cameras. And the field of view was quite large, I think 90 degrees in diagonal. But unfortunately, as you can see in the picture, the moon was quite bright that night. And it was also in the field of view at the beginning of the observations. Yes, and here is basically a video that we get from an event-based camera. And here you can see, I don't know if you can do it again, Jeremy passing by in front of the, you can see Jeremy passing by in front of the camera. And essentially, what the event-based camera records is the change in light. And that's what we call an event. And here, white pixels represent the increase in light, and the blue pixels represent decrease in light. And okay, let's look at some other objects apart from Jeremy. So here you can see a full moon that appears just dark because at the pixel level there's no change in light. And sorry, I have to keep playing it again. And we see twinkling stars here that are sort of observed in several frames very regularly. And we can also detect airplanes quite easily because they're like moving and blinking. But what about meteors? Because that's what we're after. And to do so, to detect meteors, several methods have been tested by Jeremy and his colleagues. And first of all, the event-based camera data was transformed into 30 frames per second AVI files and were fed into the FMDT software. And this is an example of how a detection works with the FMDT software. And this method has detected 15 meteors during the 2024 Geminids. Some other methods have been explored. One of them is raw data filtering that was performed by the team at the NCL lab that were the collaborators of this project. And also another algorithm is the spatter detection algorithm that was basically a built-in algorithm by the manufacturer. And again, here's how a meteor is detected with this one. And this one actually also detected 15 meteors, similar to the results of the FMDT. And last method is by Pete Goral. And basically here, raw events are aggregated in time blocks to feed every pixel exceedance to a clustering algorithm. And the found clusters are then fed a tracker that follow multiple pixel groups in time and maintain a linear propagation. And this algorithm is used by the University of Western Ontario on their low light EMC-CD camera network. And they have very fast computation time and continuous streaming of operation. It was pretty cool. And in the end, 7 meteors were detected with both systems, so the event-based camera and the classic camera during the 2024 Geminids, and so that allowed for direct comparison. And I mean, the number is low, and unfortunately, the full moon didn't let us detect more meteors, but still. Here we can see the light curves of the that were computed with the SkyFit2 software by Dennis Vida. And for the event-based camera, basically the signals allow us to derive the lengths of the meteors, but the exact photometry has still have to be performed. And it's not straightforward because the event-based camera has a log response. And still, the event-based camera has detected the meteors for longer time, as we can see, compared to the classic cameras. And that basically hints at the fact that the sensitivity of the event-based camera is higher. And as for astrometry, it was attempted on AVI extracted frames, and the frames were stacked, and a difference of 5-minute stack was performed to make sure that the still stars appear clearly, but this still didn't allow for the accurate measurement of the meteor positions. And another method was used that was using raw events and the prophecy tool by the manufacturer tool, and an automated astrometry was performed. But actually, this picture was taken during the 2025 Perseid with a different camera, and turned out that the astrometry convergence depends on the camera settings. So there is some further work to be done here. And so to conclude, the event-based camera was compared to the classic camera, and detection of meteors is quite feasible and relatively easy with this camera. And astrometry can also be performed thanks to the twinkling nature of the stars, but for certain cases it still has to be explored. And photometry at first, as Jeremy says, seemed like a nightmare, but because of the log response of the event-based camera, but it's still not impossible, and it's currently work in progress, this part in collaboration with Pete Goral and Dale Giancono. And so stay tuned for further results. And if you have any questions, maybe it's best to ask Jeremy, not me. And he should be available online, I believe, and available by email. So yeah.
We see Jeremy online for sure. He's here.
So yeah.
Okay, sure, sir.
So what is the rough price tag of these kind of cameras? Are they more expensive or about the same than usual cameras?
Again, I think that's best to ask Jeremy. I'm not quite sure about the price.
Jeremy's so far has replied, yup. It's 5K for IMX 636.
5K.
Yeah. Not cheap.
Yeah. There's another.
Okay.
Oh, sorry.
Yeah, thank you very much. It was quite interesting. I was wondering if it wouldn't be possible to turn any video camera into an event-based camera with a system behind it that does the math of the changing of the pixel values. Did you make any research about that?
Did Jeremy answer anything?
Jeremy?
I
Jeremy, did you hear this? You want to reply to that?
honestly, I don't know. Probably not, because I think at the base level, the way these cameras work is quite different. And I think that's why Jeremy wanted to test it.
Yes. Jeremy said, not that I know of. It requires change at a pixel level.
Yeah, exactly.
So-
So I think the sort of concept of these cameras are quite different. And so I don't think that a classic camera could be turned into an event-based camera, because it basically detects light changes at the pixel level, and I don't think that's how a classic camera works. So, but you can maybe further discuss it with her.
I just want to say that also Jeremy said after the 5K euro for IMX 636, he also said CIE equals prophecy. I don't know what it means, but I guess it's important. Oh no, depending on the market, the evolution of the price may go down. Just so you know. Pete Gorell also wanted to point out key is microsecond resolution. Okay, sorry. Oh, company, it's the company. Profees is the company, whereas the IMC come from. Okay, we thank our speaker again. And now we invite Serco with his talk on what have All-Sky 7 and the Gartner hype cycle in common. Good question. Who knows? Now we're gonna figure it out.
Lipton, be sure to find what I need.